All right, I am going to record this lesson, and here's why. The 11 o'clock class, I apologize to them profusely. You know, I worked very hard at creating these lessons and really thinking them through. However, I did a bad job of that with the 11 o'clock class. So from when the 11 o'clock class was done before our class started, I have made some alterations. And I mean, maybe they felt it went okay, but to me, I felt my lesson was a fail. And sometimes that happens, my friends, like it's nothing to be ashamed of. I mean, here we are at week 15. You'd think all of my failed lessons would have been at the beginning of the semester when we're just trying to figure it out. But no, it happened to be this morning. And so thankfully for your class, whatever happens in the 11 o'clock class, I'm always making tweaks to what we did at the 11 o'clock class so that you guys get the better version of the lesson. So kudos to the 2 p.m. class. But I wanted to record it for them in a cleaner fashion in case they wanted to go back and look at some pieces of the puzzle if they wanted a refresher or wanted to see something again. I don't think it was my explaining that was bad. I really think it was the way in which I tried to use the manipulatives didn't work so well. There was a lot of dead time as I was trying to create some things, and it just really wasn't clean. So even though I had it planned out, it didn't go quite how I thought it would. So keep that in mind. It doesn't matter how much of a seasoned teacher you are, sometimes you're just going to fail. And that's okay. That's okay. That's why we call it, practice teaching, because you practice and you tweak it and you do better next time. So with that, today they did all these pieces too. I just tweaked some things within the lesson to make it a little bit more accessible and smooth transitioning, if you will. We're going to start off today. We're still going to dive into fractions. We're going to do some adding and subtracting with fractions today. But we're going to do a new class starter called Two Truths and a Lie. And we haven't done something like this yet before. So we'll do this in small groups, and then we'll do adding and subtracting, and then we will not have time for small group practicing. So we'll pick up where we left off today with class on Wednesday. What you should be working on is your 8th choice board, as well as the 5th grade Khan Academy. And I have to say, just like the 11 o'clock class, I was thoroughly impressed with your projects. I know some of you got wrapped up in trying and worried about, how the video should look or the video editing, whatever it might be. You weren't being graded on your video editing skills. You're being graded on the words with which were coming out of your mouth. And it was exciting to see that so many the 11 o'clock class and your class in combination had worked with things that we've been doing in class and really starting to make the connections. So you're translating and transferring what we've done in class with the littles that you've been working with. And it was very exciting to see how excited each one of you were, especially in your overall reflections. You guys were all just so excited with what you had done and proud of yourselves for the accomplishments that you have done, and very well deserved at that. With that, then let's hop down to slide 2. Again, I am sharing my screen, otherwise it won't pick up what we're doing. Like the recording won't pick up what we're doing, but I'm down here on slide 2. In your group, I would like you to determine which one is the lie. So there are 2 truths and 1 lie. I want you to use this space to detail your reasoning, why you chose it was the truth, why you chose it was the lie, whatever it might be. Defend your reasoning within your group. So I'm going to break us up into groups now. And when your group is done, please just come back to our main room. Breakout rooms. All right, rooms have been sent out.
I have a question for today's tasks before I forget.
Yep.
Are we able to redo the choice board 8, or should we do it early and see what our score is? And then to see,
Oh, I see what you're saying. If you feel with your 8th choice board, it's not due until next Friday.
yeah,
But if you're feeling uncertain, I would definitely do it early to allow yourself enough time. I will put a deadline on all of those revisions coming up next week. I'll let you know when that deadline will be. It'll be the following week, probably by Wednesday of the following week.
so like the 5th.
Let's look. Nope, your choice board is not due till the 7th. So if you wanted,
Oh,
so I would allow you revisions through the 12th.
oh, okay.
Does that make
Because
sense?
I want to redo 2 others. They're not bad, but I would like a better score. But
Yeah.
okay.
Yep, and
Thank
I'll
you.
announce that next week as well, in case
Okay,
others
sounds
are
good.
hanging on to it.
Okay, sounds good.
Hey, no one came to my breakout room, but someone's typing on like group 1. So I'm wondering.
That was
Taylor,
probably me.
Oh, okay, perfect. Then that's fine. That makes more sense.
yes, Taylor was
Okay.
asking a question, so she was hanging out with me
Okay.
in your group. So if you
No
guys just
worries.
want to hang out here, you can hang out here. I'll mute myself and I will turn my camera off if you guys just want to hang here.
Okay.
Oh, okay. Sorry, Caitlin.
Oh, no worries. I was just like, something doesn't seem right here.
Okay.
Um,
Then should we just like share the screen or just do it separate?
When,
Oh wait. Someone is on group 1.
Oh, so that wasn't you.
No.
Okay. It's all making more sense now. Yeah, someone must have been on the
Like
wrong.
they're moving stuff. Is that you?
I just added a text box, but there was someone else there before.
Oh, okay.
Anyway, so like right away, the bottom one I see is pretty, I mean, it's true, and then I'll show the addition for it, but
I think 1 looks true. It's 2.5.
yeah,
3 3/5. That would be around 0.60. 60? Yeah, 20, 40, 60. Yeah, that would be 60. That's pretty close. I don't know what that. Yeah, that looks right. 1 looks right, but that's just based on.
but I mean, you can only guess so much.
Yeah.
With that. Oh, sorry.
No problem.
I did that. Yeah, how should we show that? I mean, this one-
Just say, or I can type it to estimated around correct place on line.
Yeah. And then I'll just add the 2 in this one maybe. Or for number 2.
Pardon?
And then I'll just add for number 2. Like I'll just add
Yeah.
another show there.
Okay. 6 and 1/10, right?
Yeah. I'm just always I always like triple check on those.
Yeah.
On the bottom.
And then the rabbit, that's 5 and 1/4. So.
Oh, well.
It's the other way.
Okay.
Gator eats the big one or something like that.
Well, that's what I still say.
Yeah. Okay, well, that was pretty Easy. Oh, people are back. Okay.
We'll wait a few more minutes for our classmates to come back. Looks like we're almost all done. All right, it looks like we're all back here. I'd like to know, what strategy did your group use? Mariah, can you tell me, you and your partner, which group were you in and the strategies that you used to determine which one was the lie?
We were group 4 and we just focused on common denominators. Well, I guess for the first one, it was just like visualization, just looking at the number line. And then for the next two, like you can see in our work, we just found common denominators and then added them together and could see if it was true or false.
Okay, so you guys relied heavily on arithmetic to get you there.
Yes.
Did any group do something different outside of arithmetic?
Well, I don't know if it really counts, but we were in group 2. And so we looked at the second one in particular. We noticed that like we're trying to compare like 5 1/4 plus 3 3/5 plus 2 1/2. And we saw that like 3 plus 2 is 5, and you already have that extra 1/2 fraction. So 5 1/2 is already greater than 5 1/4, not counting the 3/5 from the 3.
So you used number sense in order to see which one was larger or smaller. I mean, just kind of, instead of actually computationally verifying, you could reason why one was larger than the other. Okay. Anybody else do something different? I want to draw your attention to the note section. Each one of your slides in the note section has the source. And I just sometimes find the weirdest things when I'm scouring Twitter because I follow all the math nerds. So feel free to see what Mr. Dunkelberger has to offer. I stumbled across this 2 truths and a lie a few weeks ago. And I thought, well, gosh, that would be perfect when we're thinking about adding and subtracting. This has mixed numbers. We're only going to be focusing on less than 1 values today, but the idea still stands the same way. We're going to use some number sense to help us. So I'm going to continue utilizing sharing my screen with you for a while, just because if I don't share my screen, then when you record, then you're just seeing our tiles. You're not actually seeing what we're doing. On the left-hand side, I do have a set from Mathagon, a virtual manipulative fraction bars, and I came across this and I'm really liking how it works. I do have the fraction bars already set up, but just to give you a little tour, if you will. So let's say I want the half fractions. Notice that they're stuck together, no matter if I grab the right side or I'm grabbing the left side. This just turns them if you'd want them vertically or however you'd want them. But you can split the tile, and then when you split the tile, you're able to grab one away so that you truly do have of half of a tile, which is nice, especially if you're going to compare some fractions together. So if I split these tiles here, noticing I'm grabbing the far right to unhook them, and you can then interchange them and intermingle them as much as you need. I also like this one because it goes down to 12ths and everything in between. I like the color coordination as well. Further, you could utilize fraction circles if that is more your thing, fraction circles. So here's our whole. You could easily put a third into here and intermingle and turn and rotate items to put things together. I thought this was a unique tool that kind of allowed you to do things together. It allows you to add text boxes with equations. If you're on your iPad and use mathagon.org, then you can use the draw features. All kinds of fun things. You can even share or embed your screen as well as download an image. So a lot of really cool features for free here. They have a lot of other pieces too. They've got some algebra tiles, spinners, and dice rolling if that's your thing. There's some tangrams, which are a nice piece. And it's just some other things here. So we're on under fractions, and I just clicked the fraction bars. I already do have the fraction tiles laid out for us. I'd also like to introduce you to an add-on that comes within Google Slides. And anybody can grab this add-on. It's a free add-on. It's called Hypatia Create. And I found it by clicking add-ons in Google Slides and then get add-ons. And then I found Hypatia Create. I specifically like the edit math will have a pop-out window for you, but I prefer the mini editor, which puts it off to the right-hand side for us. I don't know how many times I have to say, don't show this again, we know. So the mini editor, notice it just hits off to the right-hand side because we would like to be able to write fractions like 5/8 plus 1/2, except we don't have that feature when we add in a text box. When we add in a text box into our Google Slides, we notice if I wanted to have 5/8, I have to go 5\8, which was what a lot of you were doing in our warm-up activity. And ideally, it's sometimes easier to follow when we have fractions that are listed vertically from one another. So I'll show you how to use the Hypatia Create. And please feel free to include it with your add-ons. Once it's on your add-ons, every time you open a Google Slides, you have that option to bring in the mathematics. You can also see that it has a bunch of different other types if you wanted to do some algebra. So if anyone's working on matrices, or if you have subletters, exponents, radicals, those things. But I just stick with and there's some basic ones that have the nice, neat multiplication. So those boxes, addition, subtraction, all those fun things. Let's see, we were in here. All right. I use this a lot with my pre-calculus class, which is why you see on my recents that I have like sine, cosine, tangent, and things like that, because we frequently use those in pre-calculus. But what I've got here is we've got 5/8 plus 1/2. So using my fraction tiles, my top line has the 5/8. I'll make this a little bigger for us. There we go. I've got the 5/8, and it does look a little different than the eighths if we were to pull out here, but it's the same idea. I really like this polypad one with Mathagon because each one of the littles are labeled pretty clearly, where these you actually would have to count. Yep, there are 5/8 of them. Well, and if I want to add 5/8 plus 1/2, I know that I'm going to be over my whole here, but I don't really know how I can add them together with how much I really have. So what I did was I converted my half into 4/8 because I know that 4/8 is the same as 1/2. So what we did here was we took 5/8 and to that we added 1/2, but ideally do, but ideally that would be the same then as 5/8 plus 4/8. And using my fraction tiles, I could see that yes, in fact, 4/8 is the same as 1/2. Well, now that they all have the same unit size, I can add them together. If I have my 4/8, which is 4 plus 5 more, gives me 9/8. One of the very common misconceptions when we add fractions is that students like to add the denominators together. The denominator simply tells us what unit we're working in, what size fraction do we have. So that's why 5/8 plus 4/8 is 9/8 and not 9/16, right? Because our size is eighths, not 16ths. And then of course, when we hit insert, which what I like about this Hypatia is that it makes it like a picture, so you can drop and drag it wherever you need. You even can alter the size of it right within your slide, which is a really great feature that this offers. Now, we could also say that 9/8, when we're looking at the unit, the whole is 8/8. We see 1 whole plus 1/8 more. So we could say this is also the same as 1 whole and 1/8 more. And by doing so, notice how I'm going to update then my piece, and then it automatically will put the updated answer in there for me, which is really also another cool feature of Hypatia. All right, our second one, 2/3 plus 2/9. So the two red ones represent 2/3 of my whole. I also have 2/9 of my whole, but how am I really going to add them together when I'm not quite sure? You know, I'm not going to be quite to a whole yet. I'm going to be over here somewhere. So what I did then was convert my 2/3 into 9ths. So 2/3 is the same as 6/9. And we can see with my pink pieces that yes, in fact, 6/9 is the same as 2/3. So what we did here was we said, well, 2/3 plus 2/9. We said, let's do center, is the same thing as 4/6 plus insert a fraction 2/9. I'm sorry. 4/6, yes, it's the same, but 6/9, goodness gracious. So now we have 6/9 plus 2/9, and I can see that we've got my 6/9 in red. And if I add 2 more 9ths to that, I have my total, which I put in green. So we could see all the pieces together. We see all the pieces together gives us then 8/9. And I already had decided that if I were to add my 2/3 plus my 2/9, obviously I'm not going to be close. I'm not at 1 yet. So kind of using some reasoning as I'm using my fraction tiles to help me, and then just pairing it with our number sentences here to help us. All right. Now I have 5/12 minus 1/4. Well, we know when we have subtraction, it means to take away. So I have on our board here 5/12. So if we count, there's in our whole, I have 5/12. In the same size whole, I also have 1/4. And if I take away 1/4, that orange piece, I see that 1/4 is the same distance or the same length as 3/12 on here. So remember, when we use take away, we're actually trying to take away or cross out, which is what I'm going to do here. I'm going to cross off the same amount, which is 1/4 or 3/12 of my box here. And therefore, when we do that, I see that we are left with these 2/12 or 1/6. So 2/12, let's make it transparent, make it thicker. So what we ended up doing was saying, well, I have 5/12, and I want to take away 1/4. We'll do center alignment. We said that 5/12 was the same, but ideally we also took away 3/12, which is the same as 1/4. So this equaled altogether 2/12. Or if you're going to make your kids reduce, 1/6. I don't have strong feelings about requiring reduction. We always say, what is it the same as? What is it the same as? But then we always require reducing the fraction. If they're the same, why does it matter? Kind of my opinion here. All right, one more. We've got 2/3 minus 2/12. So I've got 2/3 of my whole on the top, and I've got 2/12 on the bottom, or the middle, excuse me. And yes, I could certainly take away that 2/12 on the top here, but what would this leftover, what is this leftover? How much is this leftover? How much is that? We're not quite sure, right? We're not quite sure. So what I did below is I converted 2/3 into 12ths because I could easily see that I can then take away 2/12 from my 2/3 when it's in 12ths, or 2, 4, 6, 8 12ths. And then I see what's left over is easier to look at and identify than the 2/3 in the very top part. So in this instance, we had 2/3, oops, and we subtracted 2/12. We said that would have to be the same as, 8/12 minus 2/12. When we actually took away the 2, I can count 2, 4, 6. I have 6/12 left over, which is the same then as 1/2. And then I'll insert that picture in. There. So using fraction tiles is a great method because it can allow you to see the size of some fractions and also can help you find the common denominator themselves, which, as we know, is a very intricate woven piece to fractions when we're adding and subtracting. So let's head down to slide 11, either on your own screen or my screen. We have 2/3 plus 3/4. We have 2/3 plus 3/4. I've got on my number line 0 and 1. So if I were to think about 2/3, I would have to split up my between 0 and 1 into thirds, and then I would have to split from 2/3 if I want to add more to that, specifically 3/4. Then I'm looking at splitting it into fourths. And how do I know where they might be located? It can be a mess, right? So I'm going to start off by saying I know that 2/3 is equivalent to 4/6. And that also is equivalent to 6/9, which is also equivalent to 8/12. I'm going to just move this over here. So when I start at 0, and we're going to start doing, let's see, this shape. Let's grab ourselves an arrow. We're starting at 0, and we need to go 8/12. And wouldn't you know, my friends, these are cut into 12ths themselves. So 1, 2, 3, 4, 5, 6, 7, 8. And of course, I lost my spot. 1, 2, 3, 4, 5, 6, 7, 8. All right. From here then, from 0, and we went 8/12 more, we could have done 4/6, we could have done 6/9, but I'm choosing 8/12 because when I look at 3/4 and needing 3/4 more, I'm going to do the same thing. What is 3/4 also equal to? Well, this is also equal to 6/8, which is also equal to 9/12. This also tells me that most likely, since 2/3 and 3/4 are both pretty close to 1, that this number most likely is going to go over 1. So from 8/12, I'm going to add on 9/12 more. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9/12 more. Ultimately, then, we had 8/12 plus 9/12 more, which should give us 17/12. And we know that is larger than 1. 1 is 12/12. So really, this is 1 and 5/12. So we went 5/12 past the whole. Again, just like the previous page or the previous one, we're still relying on finding fractions that are the same because we need their unit part of the fraction to also be the same. We need to be in the same size piece, which is why sometimes fractions can get so difficult for learners because they want to treat them just like any other number, but we can't really do that because they need to be the same size piece in order to combine them together. All right, let's do a subtraction one. Here we have 2/3 minus 5/9. Well, we already have 2/3 from above written in all of its glory with its equivalencies. So, there is a 9th, right? We see the 9th. We'll add a little visual here, and then we'll turn it to transparent. We see the 9th here. Oops, I didn't turn it transparent. There we go. We see that 2/3 is the same as 6/9, but we need to go backwards 5/9. So I took my number line and divided it up into 9ths. This time when I use my arrow, we're going to start at 6/9. 1, 2, 3, 4, 5, 6. Oop, right here. 6/9, but now we need to go backwards. Let's see here. 1, 2, 3, 4, 5, 6. From, 6/9, and we need to go backwards 5. 1, 2, 3, 4, 5/9. So when we went backwards 5/9, we needed one more. That's why I was confused. We need to move this guy over one more. There. We are now at 1/9. So we know adding means we start at 0 and move to the right on the number line. Subtraction means that we start where we're located and move left on the number line. We'll just make this big and stick it over the top. So 1/9. All right, let's head down to slide 12. We're going to talk about the area model. So you'll notice on slide 12 that I've got these really weird boxes. Looking at 3/4 and 7/8 and the box that I created, would you use the chat box to tell me what you notice about the box with comparison to the fraction? Will you tell me what you notice about the box right next to comparison of the two fractions that are listed? Put your thoughts and ideas in the chat box for me. Oh, look at these. A 4 by 8, which are the denominators of the fraction. Columns and rows are the denominators themselves, and Caitlin follows up with the denominators are controlling the length and the width. Absolutely. That is what's happening. I am using the length and the width of my whole box to be determined solely on the denominators, to be determined solely by the denominators. It doesn't matter if I'm choosing, notice how my first fraction 4 is broken into 4 columns, and I did 9 columns along the top. They could go either or. So I could have 8 columns with 4 rows and 6 columns with 9 rows. It doesn't matter. It doesn't matter at all. What's important here is that I am using one for the rows and ones for the columns, okay? And noticing that it doesn't matter how big your box is, we just have to make sure that the whole is the same throughout. I'm actually going to make 2 of these. So I'm just going to copy this box over here. By copying it, I know that these 2 whole boxes are the same size. One of these boxes, I'm going to color in using my fill-in feature. I'm going to color it in 3/4. So I did 3 of the 4 columns. Whereas the other one, I'm going to color in, let's do this one yellow, 7/8. So one is 3/4, one is 7/8. Notice the little tiny boxes. Are the tiny boxes all the same size? Are the decomposed little boxes in my whole, are they all the same size? What do you think? Yeah, all those little boxes inside my whole are the same. And actually there is 4 by 8 of them. So there are 32 little boxes in each one, right? So if there's 32 little boxes, I'm adding these together, right? The left one is 3/4, the right one is 7/8. I want to add these all together. So maybe what I'll do is color in 8 more of these and borrow some of these colors. I'll have part of a whole box here. So if I color in a yellow box here, I will make this box nothing. If I color this box a yellow box, I'm going to make this color nothing. So notice how I'm bringing them together. We need 2 more boxes that are yellow. And then we are going to get rid of these 2 boxes here. And we need 4 more to make up a whole. And get rid of 4 more here. So when I add all of my little boxes together, notice I've made a full whole. I colored in an entire whole box, but I have a portion of my second box over on the right-hand side. So what we did here, it's going to make our, here we go. We started with 3/4 and we added to our 3/4, we added 7/8. This is the same thing then. Well, 3/4, we had 32 as our denominator. So 8 times 3 is 24. And on the right-hand side, we had 32, so 28 altogether. Right? When we added all of them together, all of the blue plus all of the yellow, we were still in 30 seconds, but we had 28, 52, 30 seconds. We saw that made one whole box. So we moved some of our yellow parts over with 1, 2, 3, 4, 5, 20, 30 seconds left over. Now, my friends, I know that I'll let you reduce the fraction itself. By doing the area model here, was that the smallest denominator we could have chosen? Was that the smallest denominator? I don't think it was the smallest denominator by any means. If I'm looking at 3/4 and 7/8, 6/8 is the same as 3/4, much smaller fraction. But at the same time, it doesn't matter what those denominators are. When they're the same, we still can add the pieces together. So if you're having a student struggle with what could my common denominator be, because a lot of students get hung up on that, why not use the visual area model to help you? Let's try one where we're actually subtracting. So I have my whole. Along the top, I broke it into 9, and along the left, I broke it into 6. I'm going to make a direct copy of this off to the side just so we can visually see a picture of what this might look like. Notice that my holes are a little larger. Again, it doesn't matter as long as your hole is the same size. It doesn't matter how big that hole is. So they are a little bigger than the hole from the previous one, but that's just sometimes the way it is. All right, I need 5/9. So I'm going to highlight 5 of the 9. Oops. There we go. Let's color them. Oh, we should probably. There we go. Then we can actually see the pieces in between. So that is 5 of the 9 columns. We also need 3/6. So 3 out of the 6 rows. We'll do those mustard. But noticing that when we do this, it's decomposed into 54ths. But I need to take away, right? I need to take away all of these yellow ones from my original. So this is what it just looks like. I need to take away 8. Let's see here. 1, 2, 3, 27. I need to take away 27. Let's indicate 27 of them by turning them red or putting an X in the box. It doesn't matter how you want to do that, if whatever is easiest for you, but we know that we need to take away means that we're needing to get rid of something. So I'm going to turn them red, the box red, if we need to get rid of. We need to get rid of 27 boxes, right? 3 times 9, so 27 boxes. So right here, we've got ourselves, let's turn them red. Here's 1, 2, 3, 4, 5, 6. Another 6, we're getting rid of 12. Another 6, we're getting rid of 18. Another 6, here's 24 that we're getting rid of. And we need to get rid of 3 more. Oops. 24, 25, 26, 27. Yes. So then what is left when we took away the 27 yellow ones? So if this bothers you to have these yellow ones here, I just used the right-hand side yellow boxes to indicate what it looked like, what 3/6 looked like. So if that bothers you, get rid of it. And the red is meaning that we're taking away. So what's left over then are these 3 littles. We're going to make it transparent and we're going to make the box thick. So what was left over was 3/54. What was left over is 3/54. Okay. Again, not the easiest way because we could look at 9 and 6 and say, well, 18 is the common denominator. 18 is the common denominator. That would make for much smaller fractions, for sure. For sure it would. But sometimes we need a different visual to get there. All right, let's look at this last slide. This will be our, oop, I lied, it's not our last slide. Almost last slide. Let's head down to slide 13, where we will talk about decomposition. Decomposition is super interesting because we did a lot of decomposing. If you think back to our number bonds from way back, what seems like it was still 5 feet of snow on the ground. Number bonds where we decomposed our numbers. We decomposed whole numbers. We've decomposed with multiplication. We can decompose fractions as well. So I'm going to start off by decomposing 3/4 into 1/4 plus 1/4 plus 1/4. It's unit fraction. When I'm looking at 7/8, and maybe I will insert this now. Here it is. I'm also going to decompose 7/8 into, I'm going to do 1/8 plus itself 7 times. I know it seems redundant, but I just want to show you a variety of different ways in which we can decompose our fractions outside of just the unit ones. In the next couple of examples, you'll see a couple alternatives. You have to really be a little creative sometimes, but 1, 2, 3, 4, 5, 6, and 7. We'll put that baby in there. So 3/4 and 7/8 together. We want to add all of these pieces together. Okay. Noticing that with 1/8 plus 1/8, I know that 1/8 and 1/8 together is 1/4. So kind of thinking in terms of mental math strategies, what I know about fractions, 1/8 and 1/8 is 1/4. So then if I combine together these 3 1/4 with 2 1/8, that makes a whole. And so if I have a whole, the leftovers are 1, 2, 3, 4, 5/8. For some reason, it wanted to get rid of my editor, so we will just open it up. No edit access. I don't know what that means. Let's try doing the big one. Of course that would happen. In any case, we will go back to the traditional modeling since for some reason it's having conniptions. So we had one whole, right? Because the whole box represents one whole with 5/8 left over. So 1 and 5/8. It shouldn't surprise us that we are over a whole since 7/8 is a pretty close whole in general. So that shouldn't surprise us. All right, let's look at this next one with decomposing. We have ourselves 8/12 minus 3/6. I know that 3/6 is 1/2. I know that's 1/2. So if I could decompose 8/12 into a half, notice what we're going to do here. I'm going to put it in parentheses. 8/12 is the same as 6/12 plus 2/12. Right? 6/12 is 1/2. And I'm going to subtract 3/6 from there. I know that if I take, let's insert a shape. If I look at 6/12 and I take away a half, since they're the same, it becomes 0. So if it becomes 0, the only thing that's left over is 2/12 or 1/6. And again, don't put the emphasis on reducing. Right now, our emphasis is on adding or subtracting, utilizing these different strategies. So here I noticed that 3/6 was 1/2. That is what we recognized. However, that strategy probably won't work with 5/9. Since half of 9 is 4.5, that strategy is not going to work. We're going to do a little something different. So instead, I'm going to decompose into thirds. I'm going to decompose into thirds. I know that 5/9 is the same as 3/9, which is a third, and 2/9 more. From that, I'm going to take away, again, thinking about thirds, I can decompose 3/6 into 2/6, which is a third, plus 1/6. Rearranging my terms then, this is the same as 3/9 or 1/3 minus 2/6, which is 1/3, with our leftovers of 2/9 minus 1/6. We're going to have to come back to that in a second, but I know right now that my 3/9 minus 2/6, because I know that they are both 1/3, so look how clever we are here. Because they are both 1/3 creates a pair of zeros, so I don't even need to worry about them. I just have to look at 2/9 minus 1/6. 2/9 minus 1/6, which we can rename. So we'll put it, we'll use rename into fractions we know. This is the same then as, and we're going to talk more in the next slide about instead of equivalency. How do we get equivalency? Which is, we'll hold on to that. All right, so 4/18 is the same as 2/9 minus 3/18. So when we reduce, or we subtract, I should say, is 1/18. So we decompose to get rid of some of the subtraction. Yes, of course, we ended up having to find the common denominator anyways. However, it's nice to be able to be really flexible with some of these numbers, really flexible with equivalency, which is why the next slide is one I think that you guys are going to like the most, simply because it is the most similar to the way you probably learned using the rule, right? The rules of fractions. Equivalency is just like we have said. So notice that when we first started out, we were in the concrete modeling with the fraction tiles. We then kind of worked our way a little bit more abstract. I would definitely say that the area model is also concrete. Not as concrete as algebra tiles, since you're kind of manipulating a visual model. And then when we go to slide 13 and 14, these are definitely fifth grade type fraction strategies, especially with respect to decomposition and equivalency, moving to the abstract, right? No picture representation, no number lines, nothing, more abstract. So when I think about 2/3, let's see if our add-on will work. No, oh dear, that's okay. Thinking about 2/3, I'm going to write what 2/3 is equivalent to. 2/3 is equivalent to 4/6, which is equivalent to 6/9, which is equivalent to 8/12, which is equivalent to 10/15, and 12/18, and 14/21, and 16/24. So I went a long way here, right? We went a super long way. We might have to move these down here. And then when I look at 1/8, I say, well, what is 1/8 equivalent to? Well, 1/8 is equivalent to 2/16. 2/16, which is equivalent to 3/24. Oh, thank goodness. We found them, right? We found what they were equivalent to so that we're in the same unit. Oh, a little too much. So looking at 16/24 and 3/24, I can say then that 16/24 plus 3/24 is in fact the same thing as 19/24. Doing the same thing, except subtraction, happy day. I already have the equivalent fractions, except this time we are going to be subtracting the equivalent fractions. Same idea though, except we're subtracting 16/24 minus 3/24, so 13/24. How do we know when to stop, right? How do I know, like 2/3, we went forever and ever and ever, it felt like, writing equivalent fractions. I mean, you don't know when you need to stop. So if you just did a few of them for each of them and keep going and building until you find that common denominator, please do so. It also saves on students having to remember facts all the time. They can just write the equivalent fractions to themselves. So let's start with 5/6 minus 1/8. We already have the 1/8 equivalencies. We already found those, so that's nice from above. So let's work on finding those that are equivalent to 5/6. So 5/6 is the same as 10/12, which is the same as 15/18, and is the same as 20/24. Again, we have the equivalent fraction with the, just so happens to be the 24ths again. And in this case, we're subtracting. So 20/24 minus 3/24 is 17/24. All right, I know I threw a lot at you today, but I am much happier with the way this came out than the 11 o'clock class. Oh, I felt bad for them. So I appreciate you allowing me to record today's lesson. I'll also put this in Blackboard if the link, I'll upload it to YouTube as an unlisted video and put it in Blackboard if you desire to go back and watch certain pieces. We will pick up on slide 17 on Wednesday together so that you have enough time to practice these 5 different strategies for adding and subtracting fractions. But what I want to know in the chat box for our exit ticket today, in the chat box, I want to know, have you seen or used these strategies before, and explain. Have you used or seen these strategies before, either using them yourself? Have you seen them in a practicum? If you've never seen them before or you used them when you were learning, tell me a little bit about these strategies as your exit ticket for today's class. I'll stop sharing and stop recording.